Hi, this is training session number 2 for the JavaScript training that we're going through for Visalia. My name is Darren Campbell. I'll be talking about JavaScript functions. And JavaScript functions are very similar to other functions you've used in other programming languages. And one of the things I wanted to start out with is really very simple. This traditional way of defining a function with a name, an object passed in, and have it do something with that object. Very simply, I have an object called myProgrammer that I initially set first name to Darren. I have a couple of other properties associated with it that I don't use. I pass that object into this function and access its first name property and change it. So when you run it, where's Firefox? There we go. Alright. When it's run, I wrote out some console debug so that you could see the sections very easy. Write out the first name of my programmer, Darren, after the call, Darla. It's a straight function that we use everywhere else. But JavaScript does something a little bit odd. Like many scripting languages, it has some cryptic ways to do things. And in particular, it has 4 different patterns that it uses for function invocations. And those are the method, the function, the constructor, and the apply. Each one has some advantages or some potential uses. One of the things that we've talked about is that we're going to have to come up with style guidelines for what types of patterns we should use. So, go back to Aptana. And the first one that we're going to talk about is the method invocation pattern. It's probably the most familiar looking, where we actually have, we're declaring an object, capitalize me. We have a couple of properties, and one of the properties, catme, is actually a function. It's a very complicated function. It simply takes my name and changes it to uppercase. I tried to keep things very, very simple. Also I show in the console debug that if you're not calling catme with parentheses, it does let you know that the catme is a function. And when you call it with parentheses, it executes it as a function and will actually have the return. So to see this one run, there we go, refresh. Here is the catme without the parentheses. So if you do have an object, it does have a property, and that does happen to be a function, make sure that you call it with parentheses. And apparently I'm not returning anything because it doesn't come back. Oh, I'm sorry, it does. This is a multi-line. I also have a line inside of the function catme. And that this is the capitalize me object. It's important to, and I'll touch on a little bit more in some of the other patterns, but JavaScript uses this to get the current context, and it can be different things in different places. Within this function, which is a property of an object, the this is actually the outer object. So catme is the function. When you're using this dot, you're actually using the capitalize me object. So I want to be very clear about what you're getting with this, because in one of the patterns it changes. So if you're ever concerned about what this is, you know, throw a debug up and write. And it should be the immediate object, but if you're in a global perspective, this will be the window object. So you have to be careful with it. Our next pattern is the function pattern. The function invocation pattern. And and one of the first things I wanted to do was to write out what this was, so that you understand what object you're working with. This is, if you notice, we're creating a variable and assigning its value the results of a function. In this case, we're not returning anything, but I'll talk about the return in a little bit as well. So let's go and run this and take a quick peek. I'm sure this is all old news to you guys. All right, let me try doing this the other way then. There we go. So in this, when we have a var and we create a name and then we assign a function to it, this object is the top level object. This is actually the window object. So it is not, you don't have the context of the right debug. You are in the window object, so you have to be very careful. We get around that by using one of two things. We basically assign the local this to a variable. And here you all know I ride motorcycles, so I have an object called my motorcycle. It's got a name, and it has a function for what should be the next motorcycle I want to buy. And we have a line in here which is very critical, where we declare the variable self and we assign this. In this case, this happens to be the my motorcycle object. But what's going to happen immediately after this is I have a var bike name, a new bike name, which is inside of the function of the object new bike, and it doesn't have any access to this object. This object it has is actually the window object. So in this case, I declared a function as a variable inside of another function, and we've lost context. So what you have to do is you have to take this object, assign it to a local, and it will see the visibility of that local. There's two naming conventions. I've seen it as self and I've seen it as that. And the cool thing is that I go ahead and I show you what this is inside of this new bike name function, so that you can see that it's the window object, and that's why we use self. Is that confusing to anyone?
Yeah, self.name. So when you say self.name, is self not the name, not the my motorbike?
It is my motorbike, but this dot name would be the name of the window object.
Okay.
Okay. When right here you have access to this, right within this function, but within this function I create another function.
Okay.
At this point, it's lost its context. It doesn't have the this that's outside here and name a new bike.
Okay.
All right. The this you're going to get is the window object. So that's why they assign this to a local, because the new bike name, it's local only to this function, right? So this is actually part of the my motorcycle object.
Mm-hmm.
So since it doesn't have the my motorcycle this object, it grabs the window object. So you can end up screwing up some things if you lose track of where you are, and this is one of the downsides of this particular pattern. But it's also something you get very used to doing. So when we go back and look at Firefox, this is the first example where I showed that you had the object. Now here I have assigned this to this from my motorcycle to self, and it is an object, and self.name is Goldwing. The motorcycle name before the change is Goldwing. When I was the debug statement that I put inside that function, inner function this, you notice that you've got the window object. So that's why we assign this to self, so that you actually have the correct object. And then after the change, I've changed the name to Victory Cross Country. So it's a little bit confusing, but that's one of the downsides of that particular pattern, is that you lose context, you lose the this. Any questions on that? Got an excitable crowd here today. Now we're doing the constructor invocation pattern, and this is what I call the quote-unquote new pattern. And this also has a couple of gotchas. Right now, everyone here knows that I have a number of children, so I can't remember their names all the time. So, you know, I want a new object of kid with the right name and the right gender, because I'm not sure what genders they are either, apparently. Let's not question my parental skills during this one, but I'm just trying to come up with very simple and easy examples outside of using foo and bar. But I have an object called kid, and it is declared as a function. It's got a couple of properties, name, gender, and with a debug statement in it, so you can actually see what kid has at that time. I'm going to instantiate a new object called my daughter. I'm going to call kid as a new object. This is the constructor pattern when you use new. And I'm going to pass in Terqua as a female. And I'm just going to check my notes, make sure I'm not forgetting anything. Anytime you use the new, you obviously get, just like in regular object-oriented programming languages, you get a completely new copy of that object. So that's the great thing. You can do with it what you want. You're not changing any global. You don't have to worry about anything. This is a brand new copy. So when we go through this, we have this name and this .gender. The first time I call it with Terqua female. The second time, and these debug statements are in the same declaration for kid. So you can see that we do have new, we do indeed have new objects. And what I wanted to show is that one of the gotchas, if you do not use the new keyword, then the my daughter object, which was the object I was creating, will be undefined. And I've actually, because I was changing the name and had not used new, I actually grabbed the window object. So what's interesting, if you don't use the new, you've actually clobbered the window.name to where it is now. Window.name is Terqua. And the actual object you wanted to create, my daughter, was undefined. So the only gotcha for this is if you are going to use the constructor method, is to make sure that you use the new.
So that's with like any object. So if you had just any object and you don't use the new keyword, it takes the window and tries to change those properties.
When you're using the constructor pattern.
Okay.
It's all about using this pattern because...
So within that new, the kid function, you're changing the name of the window instead of a new kid object.
Yes.
Okay.
Right.
So window, because if window had a gender property, it would change gender also.
Correct.
Okay.
Correct. So this is where I've set it up that the construction is that I'm going to run a function that will return the object.
So the new operator applies not to the windowed object, which is above, right?
The new is I'm doing a new kid, so it's going to go here and give me a complete brand new copy.
Oh, okay.
But if you forget, it doesn't understand that it's going to create a new kid. The lines, the results of these lines was that my daughter was undefined, and that this was the window object, and that the name I had changed was actually in the window and not in the my daughter.
I see. So you didn't create a new instance of kid.
Right.
Yeah, because you didn't explicitly declare a new operator.
So it can have a few issues. Now the one that I didn't see a whole,
What actually The kit function return.
What will it return?
Yeah, what the function returns by default.
Well, I've got a little thing on returns as well, but by
Yeah,
default,
function-
if you don't specify, the return will be undefined.
You don't specify anything instead.
Right, it comes back as undefined. My daughter comes back as undefined.
No,
Right? We're trying to assign the kid, Tarqua female, to my daughter. That my daughter, you end up with an undefined object.
Yeah, by default it returns this, and if you don't specify new, then it returns global object. If you specify new, it creates brand new objects
Yep.
with the properties that you assign to this primary. So it returns by default this.
And it returns, my daughter is going to be undefined. There's no doubt about that. But the operations it tries to perform, because you haven't created a new object, it will look, and if I had picked this.apple, it wouldn't do anything, right? I just wanted to point out that if there's a property that you're assigning inside this type of function, and that happens to also exist, at the window object level, then you're going to change it. But if you have your own unique names, then it's just not going to do anything, and you've got an undefined object. The last one is the apply, and I don't know, maybe I'm missing something. I didn't see a huge usage for it, but basically it allows you to control this in a local way. And the only neat thing about apply is any method anywhere has this .apply or .call method associated with them. So no matter what you define, you've created your own methods, you've created your own prototypes, they all have the .apply or the .call. They do virtually the same thing. They allow you to change properties on the this right here locally. And the difference between .call and .apply is that .apply expects an array as its second argument, and .call expects a comma-separated list. But they do exactly the same thing. So I'm not going to tell you if these ages are correct or not, but you can see at the global level I have identified an age of 40, and that I have a function where I'm using a variable, that same name, right? My age of 45, and that is the this.myAge, so it is the global variable that I'm changing to 45. So I'm not exactly sure when and how we might use this, but my global age is 40. I use the apply, I'm getting back 45, and the call, getting back 45. Now, one of the things that I want to talk about were function arguments, because we have an arguments object. An arguments object is very similar to an array, except that it only has two properties that an array have. You can't pop or push onto the stack. All you can do is check the length, and you can check the callee, the .callee. And that's actually kind of cool, because it actually spits out the entire text for the function that is actually the callee. So here I wanted to, let's go back to the code. All right. First of all, it's the function arguments are local only, so you're not going to see them anywhere else out there. You can set them. I'm going to be extremely disappointed if any of us have to pass in 255 arguments, but the max is 255 arguments. And the two properties I mentioned were .length and .callee. So I've got a global string that can be seen by all. I'm going to actually just create something we do all the time, loop through an arguments list and create a, in this case, unordered list.
I'm sorry, I need one.
And all right, so we've got the arguments object. I go ahead and I spit out the arguments object to prove that it's an object, the arguments.callee, which actually gives out a nice little printout of the function. I'm going to loop through, very similar to having an array.length, and do something and add to an HTML string that I'm going to return at the end. Here was the function setup, and here's where I actually call. I create a variable list HTML, and I create the HTML list. I pass in Demeter, Matt, and Manish as the arguments, and we'll go look at what it looks like in the debugger. So arguments object is an object, arguments.callee property. You'll see that it prints out the entire function, which is kind of cool. This is the function where the arguments are actually in. Now I'm looping through and I'm spitting out Demeter, Matt, Manish. This is a local string. It's only seen in the function, and we have Demeter, Matt, and Manish added to the list. And that is it for a function return. The only thing I want to mention is if you don't specify a return from a function, you still get a return, it's just undefined.
So in your create HTML list, you had no argument list in the actual function. If you would have had like a variable name there, does that matter?
What do you mean? If I had passed in?
No, in create HTML list, if you were there, you just put like string one, no, up where you define the function.
Okay.
Yeah, yeah.
Oh, put it in here?
Like if you just did there string one, but then you passed in 3 strings, what does it do there?
You can pass in as many as you want. It doesn't blow up because, I mean, if you're only looking for, it is array-like, so you have to index it to get anything out of it.
If you had string one there, string one would be assigned to the first argument, but you could still loop through all the arguments that are passed in using the arguments.
Hmm.
Okay.
I believe so. I might have to test that out. That's a good point there, John.
It is like this.
It just assigns it to
Yeah.
whatever order you have, it'll assign the
Yeah,
first
yeah,
argument
yeah.
to that, but it doesn't care, it doesn't try to.
Yeah, I mean,
It's
even
not typed very.
Yeah, arguments actually takes all of them. For example, if you specify 2 arguments,
Yeah.
but you pass 5, then arguments will be with the length 5.
Okay.
And
But
the first 2
would
will be the
assigned.
first 2 from the arguments.
Right, that makes sense.
And so everyone's going to be checking that length when they're running through the arguments list, so it shouldn't blow up. But you still might get some things that you don't want to deal
You know
with.
about arguments, so that's good.
Yeah.
You said
Yeah,
that.
And so the last thing I wanted to do is talk about a return. As I mentioned, if no return specified, the function returns undefined. And that you can stop execution early. So my funky function example, I have 3 of my family members. I'm creating that as an array, my family. I'm going to loop through that array. When I reach my brother, I'm going to return. So I'm returning undefined, but I'm also will not write out my father. And then the other example I have is we run through the array and I pretty much write out everything. So well, in this case, I'm also adding to a return string and returning that return string. So I'm showing what happens that I actually couldn't check for undefined. It actually blew up and wouldn't execute any more JavaScript if I tried to show that if you don't set it, the return comes back as undefined. So I just have that written in text. And so the first one, I've got Kenda and Brian. And then my father does not show up on the list, and the return was actually undefined. It stopped execution early. The second, I've got Ken Bryan and Kenny Lee, and that has all my family members, and it returned a string that contained Ken Bryan and Kenny Lee. Now the only and last subject I have for this was to do scope as well. Not to oversimplify things, but scope in JavaScript for the most part is pretty straightforward. We have a global scope, you have a local scope. Global scope is anything defined outside the functions. Local is local to that function. And then you have this idea of closure, which is nested functions having visibility to the properties in the immediate outer function.